Vážené divačky a vážení diváci, milovníci vědy a dokumentárního filmu. Mé jméno je Dominik Vontor, jsem asistent Industry for Science a vítám vás na 56. ročníku festivalu Akademia Film Olomouc. Jsem moc rád, že pozvání k rozhovoru k filmu In Silico přijal režisér snímku Noahem Huttonem a neurovědec a výzkumník umělé inteligence pan Eilif Muller. Thank you very much for joining, gentlemen, and very nice to meet you both.
Thank you for having me.
Nice to meet you as well. And thanks for having me today.
Noah, I have a first question for you because I'm really fascinated by your courage to follow a 10-year-long project. Maybe can you tell us something about your first intention? Did you plan to make a docu-series or did you want to make a documentary feature at the very beginning?
Yeah, the intention was always to make a 10-year film. I said that to Henry when I first went over there. I said, can I make a 10-year documentary about your 10-year promise or hope to simulate a human brain that I had just heard him, say in his TED Talk. So I kind of took that maybe more literally than other people took it, and I said, let me follow you for 10 years. So he knew that the whole time, as did everyone else at the project. I would state that was my aim. I will say that about halfway through, when the Human Brain Project took off and the timeline got stretched then to another 10 years potentially from the beginning of that project, I thought maybe I'll continue on this new trajectory for 10 years. So I started saying I'm making a 15-year film. And I even went on MSNBC and gave interviews and stuff where I talked about my project that way. So I kind of shifted with what I was seeing, and then when the open letter happened and Henry and his sort of blue brain core seemed to refocus on the blue brain work again, I kind of went back to, well, now I need to sort of wrap up my original intention here, which was always the 10-year film. Going beyond 10 years was never something I planned to do in the beginning, and I certainly never thought I would be making anything but a feature film. I had no intention to make a series of, a doc series or continue making, a film beyond 10 years. So in the first few years, I did present yearly updates online, and I would edit together the footage I had shot that year, and I would get a partner to kind of premiere it online, like Scientific American. And that was sort of a way to show that I was doing this, and kind of, it helped me to keep going in a way, because I had people giving me feedback, and I wasn't just doing this in the void. But at a certain point, I also stopped doing that, because I realized as things were getting a little more heated and controversial, it didn't serve the interests of my project to be putting the material out there every year. So I started to hold on to the material about halfway through with the intention of finishing up at the end of the decade.
The Human Brain Project was very much media exposed. So my question for you, Eilif, is how was it for you to be part of such an exposed project, and how it affected your work personally?
It's a great question. So I would say it was sometimes frustrating and sometimes a lot of fun. Like, I think, fun, you get to talk to generally interested people from the community. You get to participate in for example, Noah's movie, I think, is a result of that general media interest in what we were doing. And I think it generally reflects, we're studying the brain, we're trying to understand how the brain works, and a lot of people are interested in that, and they like to, the Blue Brain is a very visual project, and so we have, many sort of open days, and we get the general interest of the public, and they're genuinely fascinated. You could see in their faces that they come, and they're really learning something about themselves, and I think that's really a lot of fun. On the flip side, I found it pretty frustrating because I found it to be fairly common that the media spent little effort to understand or to be accurate, and that they were often pushing a particular bias. I think and we were rarely given the chance to correct that fact, or to correct, the facts that of particular media interviews. And I was left with this wish that the journalists would take more responsibility for the impact of their reporting rather than getting a particular sexy story. A really common sort of way of pitching the story around the Blue Brain was sort of the man versus the underdog. And I think, the Blue Brain Project, we were portrayed as the man, and the open letter, around 2013 were portrayed as the underdogs. And I think that we have to be careful with that, because solving big challenges requires the mobilization of resources. And solving brain diseases requires the mobilization of resources. We have to be careful with our inherent desire to criticize big projects, ambitious projects, just because they're big. And this is not just something that's happened to the Blue Brain project, it's happened to the Hubble Space Telescope, it happened to the Apollo missions, so on and so forth. And I think in 2014 was the height of this media frenzy criticizing the HBP. It was around the open letter that had come out at the time, and there was all sorts of political trouble in the HBP. At the same time, the world was fixated on the FIFA World Cup in Brazil. And the overall cost of that project has been estimated around 15 billion, most of which was public funded. And I recall feeling really, really sad for humanity that they were so hypercritical of this 500 million euro that was spent towards supporting HBP and leading scientists with the earnest aim of understanding the brain. With our, within the limitations of our current knowledge, we really had the earnest aim to push it that little bit forward, to take this chance of building this more sort of coming together project, collaborate more, and to try and solve some of the big challenges with applications towards solving brain disorders and diseases. So yet we can easily spend 15 billion for sports entertainment. And I think we, and journalists in particular, need to do more reflection into what their priorities are and get them straight. Rather than rather than feeding our animalistic urges, journalists should do more to enlighten our minds. Otherwise, they'll become a negative force in our society, I think.
Yeah, that's interesting. Noah, do you have any comment on that?
Well, I wonder if was any journalism you liked through the whole time. I mean, you mentioned the negative, but did you feel that anyone told your story correctly through the entire time you were there?
So I mean, let's just take the example of your film. I don't feel a particular animosity towards your film. I think it portrayed sort of the up and downs. I think it had a few holes near the end, but I think, you did it. I think you did an earnest job. I think my statement of, that we shouldn't criticize big projects just because they're big shouldn't cause big projects to be immune from criticism. It shouldn't cause, I think just because a project is big, we should have, a reflected debate on what's going on. And I think that's fine. But I think there was plenty of coverage that, that tried to reflect a balanced view of this side and that side. But we did have, a reasonable fraction of coverage that really did focus on a sort of a man versus underdog portrayal, right away presupposing that the big expensive project was at fault and that the disgruntled open letter neuroscientists were immediately right and could have no flaw in their arguments. And I think that's the key thing where I think that man versus underdog bias that we generally have reflected poorly on and made it, caused a lot of the political strife that I think ultimately was an external force that made the HBP very challenging. And I think, if we're devoting public funds to sort of a mission and an endeavor like that, I think we should take as a society, a more constructive critical approach as opposed to this sort of looking for the car wreck.
Well, as we talk about the criticism, how did it affect the Blue Brain project after all this criticism appeared in 2014 and 15?
That was a long time ago, but I think I would like to correct a little bit the statement. And the Blue Brain project it's always been a big project, and so it's always been the source of controversy. And I think, you can see this a little bit by how quickly the open letter came after the launch of the HBP. So the open letter came on and said that, this was a poor use of resources, that there was going to be no success in this project, and even sort of claimed that there has not yet been a success. But this was essentially came out 1 or 1.5 years into the project, right? So we hadn't even, it was coming out around the time of our first review. And so, to claim that there was evidence that we weren't making any progress, I thought was really kind of silly, but that shows that there was already this animosity even before the project is started. And that really I think that propagated from Blue Brain into Human Brain. The co-naming of the project, there was a lot of people who got confused. Is the Blue Brain project, does it exist anymore? Is there a Human Brain project? There was a lot of confusion that we had to sort of address between, look, the Blue Brain project is a Swiss-funded effort with a home at EPFL. The Human Brain project is a European-funded flagship initiative that involves many, many partners and many, many experts, neuroscience experts across Europe. It had a very balanced sort of set of voices within the project. So, ultimately, I would say the impact of the criticism on the Human Brain project is pretty well known. So basically, right around that time, there was a mediation process that was put forward that ultimately recommended that the governance structure be dissolved and then reformed. And I think that, it's what happened, but I think, we have to be careful also that, my impression of what happened after was that basically the governance structure that came afterwards was more or less the same governance structure as it came before, just with different people. A lot of the criticisms early in the project were that, the money had been awarded globally, and then that there was the way that just the resources were distributed was not necessarily transparent. I think that sort of the governance structure that was preserved more or less preserved the validity of the criticism that, it wasn't always transparent and sometimes very political who got given the money from who. I don't think that really changed much. What changed was who was doing it. And, whether they were a polarizing, someone who people felt critical of generally, or whether there was no history of being critical of that person. So, but I think what it did create is, I think what was the key issue, and where I was a little bit, where I felt that we should have thought more critically of whether we really actually do sort of revolutionary dissolution of the political fabric of the project, was that project, we have to understand, was a competitive process over multiple years and a 300-page scientific proposal. And so the award came for a proposal that had a particular scientific vision. As soon as you dissolved the project, it sort of created this whole vacuum of understanding of, are we able now to change what we were going to do? Can we shift the focus of the project? Is this now the mandate to shift the focus of the project? And that creates sort of a vacuum but we no longer have the competitive process anymore, where sort of it becomes this political jockeying process where people are trying to themselves push for their particular science over another. And I think that sort of breaking that initial constellation led to a lot of political games and a lot of jockeying. And I think that was detrimental to the focus of the project, and it was detrimental to having the project work in a collaborative way towards a particular thrust. I would like to ask the question, it may have been better at that point rather to cancel the project and then reform the competitive process such that from the beginning, the mission is clear. And I think that's important. As soon as you have sort of halfway call everything into question, then all sorts of politics starts. That leaves the door open for all sorts of games that I think made it challenging to rise to the collaborative aspect of the project that I think were so important for it living up to the dream. Yeah.
Well, from the perspective of filmmaker Noah, I know that you believed in Henry's project at the very beginning, but after all this criticism happened, how did it affect you as director of this film?
Yeah, well, I'd say that I came in a very different person, a 22-year-old who was very much bowled over by Henry's TED Talk, and that was my point of entry. So people coming, you know, but also, by the way, I had studied neuroscience as an undergraduate and had taken classes like mammalian cortical circuits, and we had studied only Henry's papers, really, from the 90s, right? And so I came in not just watching the TED Talk, I had that context too, which actually helped me believe in the vision even more, because I knew that Henry had such a legacy of doing very respected and universally praised biological experiments, and in really pioneering this multi-patch clamp technique that we had studied in these classes. So I came into seeing his TED Talk from that context. So when he said, you know, I have this vision of how to go bigger and do the whole brain, and we can simulate, we have a proof of concept, I went with it fully. I had no doubts or you know, feel any criticism yet that I had heard about that this method couldn't work. I sort of believed wholesale, and that might have been a bit naive on my part, because if I had looked back around that time too, even then people were poking at it, and you know, it was a debate. And as a sort of like awe-inspired 22-year-old, I sort of went fully in, and then I had to figure it out myself as I went, that this might not be universally accepted, that this approach to simulating the brain is going to be helpful for some of the outputs that even Henry had said he wanted to achieve in the decade. So then I got into it, and you know, 3 years in or so, I started interviewing other people and other critics. And to be honest, and I say this in the film, I would go and talk to people like Sebastian Sung or Jeff Lichtman or Chaim Sampolinsky, who all had their own kind of scientific issues with Henry, also some like personal falling outs. And there were, you know, I kept learning about, science is messy too. It's not just who has the best vision, right? People have personal falling outs, and that can color even how they talk about someone else's science. So I started to learn all this as I went.
It's important to say also they have competing big projects, right? They have their competing big missions.
Human Connectome project, yep, yeah. So exactly, so someone like Sebastian Sung, who I don't really go into what his work is in the film, but as I've encountered in many Q&As I've done, there's also a whole world of criticism about the connectomics work, right? That I don't really get into that in the film, because that really is a whole other film. It's a whole other story to follow that work, and why so many big projects and equal money to what's been spent on the Human Brain Project and Blue Brain Project at this point has been poured into that work. And many people don't believe that, you know, if you don't have data about, you know, real-time data about a synapse and what's going on chemically at a synapse, you only have structure, are you really going to get the salient information you need? So anyway, I would continue on but you asked about like my personal journey and my relationship with the subjects too. You know, that what that is comprised of a lot is I as I say in the film, I could go and talk to someone like Sebastian Sung and feel critical, and then I'd come back to Henry and I would believe again. There were a couple things that maybe happened near the end of the decade that started to tilt the balance a little bit in one direction or another. You know, I mean, certainly I make a bit of a deal in the film about the year I showed up and Henry didn't show up for his interview with me. Now, he was busy, he didn't show up for it, fine, whatever. But in a way, in approaching the end years of this film, when I was asking everyone, Eilif included, what's possible at the end of the decade? Are we going to get a mouse brain? Are we going to get, you know, I was looking for what the milestone was at this point. When I wasn't getting much back on that, or if I felt like it kept getting punted, and, you know, Henry was asking me, maybe you should continue making this film, think about another year or two, we're going to have the whole mouse brain in a few more years, just stick with us, you know. So when I didn't feel like I was getting clear answers about that after having tried the whole decade, to figure out where this was all going, I think I started to wonder if the milestones and the deadlines that are stated sometimes are really have the scientific rigor that I think even Eilif would want them to. And I even heard grumblings, within the project about press articles that had come out, the week before I'd gotten there, where Henry had been quoted making a pronouncement, and people, it'd be like, okay, well, there's that again, and there is a real tension, I think, between what you have to say sometimes to get up the public imagination and the funding imagination driven to continue the funding of the work that is a little more humble and piece by piece than maybe what you're saying in the press. And so I think, Eilif talked about one dimension of the press, not, wanting to seize on this underdog versus man story. I think there is some accountability that needs to be taken from scientists who do say things in the press sometimes that do get the public imagination going. And then people like me come around to audit that imagination and see where we actually are. And over the course of the decade, I certainly didn't see the original, vision checking out, and that's fine. But I think this, we even saw at the end of the film how the imagination now needs to sort of push the horizon to some future dates, 2030, 2050, and starting to think about, again, sort of like re-engineering the futurist mentality to keep this going. And that's, again, I'm not criticizing that specifically. I just want to show that because I think it's part and parcel with the good, humble, objective science that people are doing, is a need to tell the story about what you're doing, to get funding and to get a public imagination behind your work. And people need to understand maybe that those two things are sometimes moving in oppositional, have some oppositional tension to them.
So I would like to respond a little bit to that. So I think, the first thing I'd like to say is this discrepancy in science between, the sales pitch and what actually happens is commonplace. So this is basically well known across the board. Everyone but it's not, I think, out of a desire to mislead the funders or so on and so forth. It's that research is hard, and you're going into the unknown. You're going into the frontier of human knowledge, and one needs to, oftentimes, I think we know about the issue that the public generally doesn't want to fund fundamental research. They want to fund applied research, with some dollars behind it. Is it going to lead to some patents? Is it going to lead to some money? Yet I think that it's, pretty well established on the long term that funding fundamental research is important. It leads to things like GPS. It leads to things like lasers. It leads to all sorts of incredible breakthroughs that are the foundation of next generation technologies. The AI boom right now is due to, it was 20 years ago where the techniques were being developed and gestating and maturing that, Canada is acknowledged as having, and in particular, the CFAR organization is acknowledged as having played a fundamental role in funding research that didn't seem like it was going to pay out anytime soon. So fundamental research. So I think that we shouldn't be too critical of that. So it's important to maintain a balance, and one can get excessive about it. But I think we do need to understand that this is, that an element of that is normal. So I'd like to also challenge a little bit the word you said, scientific rigor of the milestones. And I think one has to be careful. Are you talking about management and timeline rigor, or are you talking about scientific rigor? So, even though I'm independent from the project, I'm now here in Montreal and have my independent lab, I would like to stress that, for people who have actually come and looked, and we've actually given them the details of what we're doing, there's never been any question of the level of rigor in the models that we've been building. So when we published our cell paper in 2015, the president of the Allen Institute, well acknowledged for his rigor in biophysical modeling and so on, Christoph Koch, he said this is the most complete model of the cortical column ever built. We account for so many things, and so. It's not scientific rigor that's in question here. It really is, did we get our timelines right? And, I think definitely it's the case that, at the end of the movie, I think you filmed some of the visualizations of the mouse cortical reconstruction that we built. That's definitely not a human brain. So definitely there's a discrepancy between, the promise 10 years ago and what was finally delivered. But I think, if we consider the tools and methods that have been developed, those are, basically the ability to build in an atlas, the ability to reconstruct brain matter, the ability to integrate and extrapolate from, the dense and very expensive morphological reconstructions to building the entire cortical sheet. A lot of the tools are there, right? So, the missing pieces are coming into place. And I think I don't think it is correct to say, it was totally off. There has been very important steps to have been able to demonstrate the mouse cortical column, the mouse cortical sheet, including all of the white matter, convincing, a panel, 6 panelists that this is, amazing progress that's been made. I think we have to, sort of put that in perspective. Yeah.
That's in the film. I mean, I acknowledge that Christoph came in the film and reviewed the project, and once again, it's been approved and continued forward. I didn't say the scientific rigor of the project. I said the scientific rigor of the milestones. And so what I'm talking about there is that if the milestones had been rigorously set forward and adhered to, then Henry probably wouldn't have sat across from me at the beginning of my filming and said, we're going to do a mouse brain, then a cat brain, and a monkey brain, and then a human brain in 10 years. And so that he said that to me, right? So now he's not doing science when he's saying that, but I'm saying that there maybe was a mismatch between the actual rigor that went on to get to the cortical sheet and to the achievements you're laying out, which there's no dispute about, versus the sort of continually updating milestones that were presented to me as an outsider coming in throughout that same time span. And I understand that words are not someone doing science. I'm just saying that this is a scientist telling me a 10-year roadmap that I know depends on funding and depends on all sorts of other details. But another way to handle this could have been to set out the cortical sheet of the mouse as the goal, and then get there, and then announce your next goal. Or, I probably wouldn't have made the film then, right? So that's when I say there's a paradox between the pronouncements that you have to make to kind of get people interested and get the public imagination juicing, versus if he had said, or if anyone had said, we're going to do the mouse neocortex in 10 years, I wouldn't have started making a film about that. I probably wouldn't have. So that, and that's, I don't think there's not an easy answer there. It's not, you kind of do need to get people dreaming big to move the engine forward, right? But there is another side to that. It's not just a net positive.
Sure, but I mean, a TED Talk, I mean, I think most people would allow someone speaking in a TED Talk to provide aspirational goals. When it comes down to writing the actual proposal, when you write the actual human brain project proposal, then he's putting in a timeline for how to build the human brain. That starts from the start of the HPP. But then if 2 years down the road, that sort of dream gets canceled, then what comes next? It's conditional, of course, on a lot of these things. Now, I think one could ask the question, were the HPP, if it didn't receive the open letter, if it didn't get all of that political strife internal to the project, could they have succeeded in appreciably building, the human neocortex? I think that's an interesting question.
Yes, maybe. But my point is not about the Human Brain Project. I'm talking about the first interview he gave me when I came in 2009, before the Human Brain Project was even on the table. So this was sort of independent of everything. But my ultimate point here is that my worry in this whole ecosystem is that there's a bit of a cycle of hype and salesmanship to get the engine moving. And then you figure out as you go, and you actually do achieve a much more humble goal, but you do achieve something. But because you had to do that hype and salesmanship to get the engine moving, you then have to reckon with a potential fallout in the public understanding or trust or enthusiasm for the science when they didn't see the thing you said was going to happen. And your point is that the journalists need to take more responsibility for that. And my point is that I don't know about that. I think that journalists do a pretty good job, and there are actually less and less journalists in this world today. We need more journalists. And I wouldn't put the blame so much on the journalists. I think that a little more accountability might have to be taken from the people who did the hype in the first place. Because the journalists are there for a reason. They got interested in this for a reason because someone said they were going to do a human brain. And not all scientists say that.
Well, I think it should be mentioned after this incredible clash of point of views that Henry's original idea was deeply personal. He wanted to change the status quo of neuroscience because of his son who was diagnosed with autism. So my question to you is, how do you think that the emotions affect science and scientists' work, and how it affects your work, Noah?
Yeah, I mean, I certainly found that extremely compelling, and part of the compelling thing about it for me was that I didn't know about it for about 8 or 9 years making this film. Henry is not very public about or open about this when he's talking about the work of the Blue Brain Project. I think he's had other avenues where he's explored his relationship with his son Kai, and also has a rich line of research into autism that he and his wife Camilla have pursued. So I kind of learned about that late, but I found it compelling because I think ultimately, you know, the personal connection, the personal interest motivates the reason we tell films, and it also motivates the reason we tell, you know, scientific stories and stories through science. You're telling a story by the kind of science you're doing, and the kind of science Henry is doing, I think, tells a very compelling story about his frustration with the status quo, as you mentioned, about how it's not moving quick enough, about how people can spend their whole careers studying a small, tiny circuit, but no one's really putting the information together. So I found his always, when he would talk about integrating information from around the world and building a new platform and finding a way to look globally at something like autism on this platform, I found that super compelling. And it was only reinforced by hearing later, when this biography came out by a German author about his relationship with Kai. That's when I really learned about it. And I was really glad I did, because I think it shows that Henry came into this not with some, you know, ambition to take over the world of neuroscience, but it really did come from a personal place. And I think it really humanizes him as a scientist and as a character in this film.
Yeah, I think this is really important to point out. Maybe Eilif, do you have any comment on this, on the fact how personal emotions, maybe sometimes deeply irrational, are causing the scientists to look for the goals that are simply too far to reach?
I would say that, so science is an arduous road, less traveled, and it's a labor of love. And in my experience, it takes a gushing source of motivation to persevere. And we each have our own particular source that we draw from that keeps us going down this road. You know, you're in this situation where you're, you know, all around you are your critics, and you're trying to get to the edge of human understanding. We have to constantly be studying all the, you know, recent results. We have to, you know, and we're constantly being subjected to, you know, to competition and critics, and you know, I think your idea is terrible. And so you have to come from a place where all of that, in a sense, doesn't matter. What matters is that you want to, you know, for me, it's push the truth forward. But I think everyone has, you know, their particular reason why they do it. And I think this is, you know, this is one of the key, you know, source of emotion at play in science, that without drawing from that source, which is very much emotional, it's a very much personal, it's a very, who am I? Then maybe there wouldn't be any scientists. You know, the reward structures are pretty lousy. The odds of getting going through the whole academic career and getting a tenure track position are extremely slim. The return on investment, if you consider it in terms of dollars, is just terrible. The price that your children have to pay for, you know, not being able to spend time with your kids and constantly having to write grants, and it can be decimating for many people, and yet we persevere. And I think that's probably one of the key emotions at play in science is perseverance. And it comes from, I think it comes from a very visceral level in many of us.
Yeah, I think that's true. And also with every step you make, you are closer to the 10 million cell circuit champagne. So, Eilif, what happened to this champagne? Is it still in the locker?
The champagne. So that's an interesting one. That champagne was actually for a technical challenge of scaling up the circuit building process to achieve a certain number of neurons. I believe we achieved it. It was somewhere in the middle there. I would say it was perhaps even a little bit anticlimactic. The engineer who had built done the key innovations that allowed us to do that, had kind of moved on a little bit and taken up a PhD and changed his focus. We did the cell paper in 2015, and I think that was our focus for several years coming up to that, and that's in a sense why the building of bigger circuits as such, which would entitle us to our champagne, wasn't a focus until that cell paper came out. That was really more of a scientific milestone. Then after the fact, so that we set our sights next on building a whole brain region within an atlas. So this is where the cell paper built a circuit in sort of a virtual void, flat space. The next milestone that we achieved about a year and a half later was to build within an established brain atlas the whole touch region of the mouse. And this was a circuit, if I'm not mistaken, of 2 million cells. So we'd already, I think, was it 10 million or 1 million? I can't remember the particular objective. So interestingly, the year that followed, which was the year that Noah captured, we built the whole neocortical sheet of the mouse, which turns out is approximately 10 million cells. So it was through these milestones that we had achieved those objectives. The technical sort of abilities were built up along the way, but I think the milestones in Blue Brain really took the form of scientific milestones. If we can achieve this next stage in our biological path towards building a whole mouse brain. So, but the cell paper was in 2015 was a huge champagne moment. This, I regret that wasn't filmed and didn't appear in the movie, because this was a quite an impressive moment. We've got the paper, of course, gets accepted a few weeks before. It's embargoed, but we know it's coming, and so there was a big party set up. The whole the top floor of the Blue Brain was set up with a big apéro. And then we had a countdown. We knew it was coming out around this time, and someone had set up a script to automatically check the website whether it was coming online or not. And there were other people who were checking. And then we're all sort of sipping champagne, or no, sipping something, I don't know what. At some point, someone screams, "It's out! It's out!" And quite a climatic moment ensued. It was a really important time, you have to understand. That was right around the time when the criticism was the fiercest. There was all sorts of politics even go, it spread right away into EPFL and was becoming very challenging in a lot of ways. And that paper sort of, it had been a grueling 5 years of working up towards that moment. It's an epic paper with, in high-profile journal like Cell or Nature or Science, to have 20 figures is unprecedented. The amount of effort that it takes. I mean, just when we were preparing to submit the paper, just laying it out on the floor, is a typical thing you do to get a view of. I can remember, one late 2 a.m, Henry laying out these images on the floor and it just going on and on and on and on. It was 20 main figures and 20 supplementary figures, and I just started to crack up. The scope of it all. just seemed to be, at that moment to be quite zany. And then to bring it to this moment where it provided us basically with this, this vindicating shield that allows us at that moment to defend against all the politics that had spread from HPP into the blue brain. We could really slam that paper down and say, look, we did it. We actually delivered, and some amazing stuff came out. We discovered, not only did it, produce this resource that the whole community could use, but we discovered some really important things about how network dynamics is mediated by ions and calcium, and but in particular validated this hypothesis that if you put the things together, you can reproduce the in vivo evoked and spontaneous dynamics. So in that sense, I think I wish that it sort of had the chance to come out in response, in a sense, to Zach Meinen's criticism, where he said, to paraphrasing a bit, that project is in the movie, and it's like, having all the parts of a watch and putting them all together, and you put them all together, and well, it's not going to work. And I think that you could just switch the tone of that and say, this project's really great because we're taking all the pieces of this watch that we've never seen working, and we're going to put them all together, and we're going to see whether it works or whether it doesn't work. And if it doesn't work, then we're going to be able to, we're going to be in a position to actually figure out why it doesn't work and figure out what piece is missing and to add that piece. And so I think, I find that's interesting that you get this analogy that can be, and I think this is a common theme. It's a theme of the movie. It's a common theme of all the criticisms, that an argument can be put forward, and depending on sort of what glasses you're wearing, what color is the Kool-Aid that you're looking through, you can see it as either a profound criticism of the project, or you can see it as an important strength of the project. And in that case, I think I would really like to be sitting in the room with Zach Meinen and ask him, what is the alternative? If we have all of these, 50 neurons with this impressive complexity, we do not yet know how the brain works. What alternative do we have to putting them all together and seeing that they don't work, and then trying to make the next systematic step? The alternative of saying, no, we're just going to sit in a room and think about it and do some theory doesn't cut the mustard. I think you're basically, it's sort of a debate, but it's the age-old debate between rationalists and empiricists. To say that we can figure out the brain just by sitting in a room and writing down mathematical equations, I think is profoundly misled. I don't think that's what he's claiming, but I think it isn't, and I wouldn't like to, I think Zach Meinen has done some really impressive work, and we built on some of it in the HPP. Same with a lot of our critics, Alice Fruget. I really, we have never really criticized the Connectome project. We've always been really, really supportive of this type of work, because it provides us this strong empirical data that is currently not available with our electrophysiological and cell patch clamp approaches, that'll allow us to really make that next big step in putting together the watch, to evaluating, we have some certain null hypotheses about how we think it's working, but those will, we'll have some really key fundamental new evidences that we'll get from connectomics, from a single brain, of looking at how individual neurons are correlated in terms of connectivity, looking at how individual synapses within a connection are stronger or weaker than another. These are really important things to understand how learning happens, to understand a whole bunch of things. And so I think, there is no alternative to trying to put together the data together and in an integrative way, in the reverse of the reductionistic way, that these two things go hand in hand, and we need that integrative approach to put things together, to figure out where we don't understand, what things we don't understand, and to identify those gaps, and then go and do some science to fill in those gaps.
Noah, you observed a variety of moments in the lives of people. You saw them frustrated, you saw them enthusiastic and emotional. It must be ever surprising topic to choose. Can you tell us something more about what did you learn from making this film, and what did you learn about the science in general?
Well, we've touched on many of the things that I certainly learned about over the decade. As I've said, I came in with one sort of model of how it works, and I was updating my model as we went. And one of the things I certainly learned, which I've mentioned, is that scientists are humans too, and not only that means that not only do they need great personal motivations, like Eilif has said, to do the work, and great wells of passion to draw upon, but they also are prone to just the same things the rest of us are, in terms of personal disagreements bleeding over into irrational personal disagreements, scientific disagreements bleeding into the irrational, and no one being actually the true arbiter of pure objectivity. And so I guess one of my main takeaways is that objective science, if we can even call it that, is something that's negotiated between scientists, and that is a product that emerges from the collective action of scientists, but is not owned or decreed by any one scientist. It's a debate, and truths are placed in bedrock until they aren't, and then they have to be renegotiated and replaced in bedrock. And I think that my exposure to that over the decade was sort of eye-opening for me, because I certainly came in thinking I had read these neuroscience gods writing these papers, decreeing these truths, and they knew the way that it was going to be done, and I was going to go capture the way it was done. And the reality of it is that it's much messier than that, and that's not a bad thing. It's not a reason we shouldn't support scientists. To the contrary, the more scientists there are to be in this debate and negotiation, the further it gets pushed, and the closer to a truth the findings become. So, I understand how the film is not just a positivist science booster. It's difficult. There's criticisms in the film, just as there were criticisms that emerged within my point of view looking at all this. And I just hope that ultimately what that does is it just pushes the debate further, so that people can talk out these issues, and people like Eilif and Zach Manen can now have a context of something that Zach Manen said about the work. We can have more ongoing debates and discussions, because people just closing themselves off, pursuing their own work until it's not funded anymore and then giving up is not a way to do it. And I think Eilif is one of the people I saw within Blue Brain who always believed in the community approach as something that was going to be necessary for the work of the Blue Brain Project to succeed in the world, and for these platforms to be adopted, and for the work that he put so much time into the Cell paper and to be replicated elsewhere. And Eilif would go off to hippocampus conferences and try to present the Blue Brain model to them, and I know he knew all this criticism long before I knew it. It's like they knew their critics just as well as I did. And I see Eilif as someone who values the community approach, and I've come to value that as well. And I think frankly we need more of that, because the politicking amongst these sort of great titans of neuroscience who stake their tents in these different camps and then sort of never speak to each other again for the rest of their careers, that's not a good model.
Eilif, you now work in AI research, and I have the same question for you. What did you take from the experience on Blue Brain Project, and how it affects your current work?
Great question. So so a little bit of a correction there. So I came to Montreal to work at the intersection of neuroscience and AI. So AI is, of course, a recognized world leader in artificial intelligence. The community around Mila, Joshua Bengio, Doina Prekop, Aaron Corville, and many others has really, planted Montreal as one of the places to be in further understanding artificial intelligence. But I'm actually in the neuroscience department. So, Montreal is also, it's the home to University of Montreal and McGill, which have, played a leading role in neuroscience over the years. Donald Hebb at McGill is where he proposed his famous Hebb's postulate, which has been a foundation for understanding learning in neural circuits already in the 50s, I believe. So the focus of my research is actually still very much in a continuation, in a sense, of what I did at Blue Brain. So, when I was at Blue Brain, I spent a lot of time really understanding in detail what does this cortical circuit consist. So the neocortex is very interesting because it's essentially a repeating circuit motif that is performing a good fraction of basically all of our sensory processing. It's processing language, it's processing mathematics, it's processing a lot of our higher cognitive functions and representing a lot of our abstract thoughts. And so it's, in a sense, it's the part of the brain that really is particularly has undergone particular developments for humans. I think it's this, and it's also this region that's really kind of the center and site of important aspects of learning and the adaptive learning mechanisms of mammals, but humans in particular. And so, my interest is really to build off of this really, I think, unique insight. As you're integrating all of the facts around the world about what is the circuit made of, what are the cell types, how do they behave, how are the synapses, how are they connected, how do they behave in dynamical settings? Is the dynamics chaotic? Is it reliable? So these were all the things that we were able to get unique views at the Blue Brain project. I basically need to have my foot in two disciplines. So on the one hand, I continue my insights and abilities to model pyramidal cells and their different apical and basal dendritic integration zones, to model in detail the how synapses compete and cooperate to get strengthened or weakened to learn particular things or to store particular things, but then how those changes in synaptic weights, what we call plasticity, how that becomes learning. We need also that other scale, that other perspective that's offered by artificial intelligence research that is allowing these systems to actually achieve scales where we can learn functional things, where we can recognize a face, where we can recognize dogs. And so my research is trying to bridge between these two fields using basically the old relationship of convolutional networks and the new relationship of using this feedback pathway as a way to assign credit to particular synapses that may change with respect to a particular objective. A lot of the work in self-supervised representation learning and work on continual learning. So it's a problem that hasn't yet really been solved well in the artificial intelligence community. It seems like studying the neocortex and the processes of learning will help us to make some headway, both in new ideas for how to solve some of these core challenges that AI approaches can't currently yet solve, but the neocortex we know to be very good at. On the flip side, the artificial intelligence, as it becomes closer to working like the brain works, it's providing us with sort of a leading model that's functional about how learning is actually happening. So sort of my research is basically at this interface now of working at these two scales simultaneously to understand in more detail the learning processes that are fundamental to our brains and to becoming who we are.
Gentlemen, thank you very much for this conversation. I would love to talk to you until the very morning. I would love to hear you discussing the role of science and the role of media, but unfortunately we ran out of our time. But thank you one more time for being really sincere and truly inspiring.
Thank you so much for having us and for hosting this. This was a treat.
Yeah, thank you so much as well. And I'd also like to, although we had a strong debate between, there was a few points where Noah and I disagreed. I'd like to thank Noah also for spending those 10 years and making this film about our science and our lives. And for me, I'm sure there's a challenge to squish that whole cross-section of 10 years of science into the time that he had. But I really appreciated sitting down and watching it and having those memories captured. And I think, while it raises some questions and, different people will see different things in the movie. I think it's really important. I think it provides an important glimpse to the public into the, what are we as scientists actually doing? What are the challenges and discussions and debates that we're having? And I think it's important to bring the public, especially, in recent, developments in recent years, COVID, vaccines, so on and so forth. I think it is important to demystify science and help people understand that these are humans who are doing this, that we have kids, we have families, we live lives, we eat and drink and be merry, and we have these missions that try to bring humanity forward in our fuddled ways, and I think that I really appreciate, Noah, that you put the effort in and to make this film. So thank you very much.
Oh, well, thank you, Eilif. I mean, I mentioned in the film, but I sincerely mean it again. The credit is to you and the project, and to Henry for letting me in for 10 years, which was kind of a crazy thing to do anyway. Like, to let a filmmaker keep coming back for 10 years, I don't think is usually done. So that suggests an openness to having the memories captured, and to having these kinds of things shown to the public. That because I was completely independent and I wasn't an in-house videographer for the project, that it's a bit of a risk. So I very much appreciate the openness of you and the project for having me. It certainly made what I was doing possible. I wouldn't have been able to do it without that kind of openness from yourself and others there. So thank you too.
This was truly a wholesome ending of our conversation. Thank you very much. A děkuji i vám, našim divákům a posluchačům, za to, že jste s námi strávili svůj čas. Film in silico, stejně jako další festivalové filmy, můžete zhlédnout na naší online platformě watchandknow.cz. Za AFO 56, Dominik Vontor.